All right, let's talk about your BT 101 chemistry exam. Forget the textbook, okay? In this explainer, we are laser focused on cracking the code. We've gone through years of past papers, and guess what? We're going to show you the exact questions that pop up over and over, and, more importantly, exactly how to answer them.
Okay, so here's our game plan. Super simple. First, we're going to show you how to crack the exam code itself. Then we'll dive right into the perfect answers for those big recurring questions. You know, the ones on atomic size, energy trends, and all that S&P block stuff. And then we'll wrap it all up with the one thing you absolutely have to take away from this.
All right, let's get right into it. We're going to start by revealing the secret to studying smart, not just, studying hard.
I mean, look, you've got this massive syllabus to cover. It feels totally impossible to know what to focus on, right? Like, where do you even start?
Well, the answer is actually way simpler than you think. You look at what's been asked before. It's that simple. When you start digging into those previous exams, you see it. The same core concepts and sometimes the literal same questions pop up again and again. And those are the patterns we're going to break down for you right now.
Okay, let's jump into our very first and, honestly, the most frequently asked question. If you master this one, it's like building the foundation for everything else in this unit. And it's all about atomic and ionic size.
And boom, there it is. This exact question, or something super close to it, is practically a guaranteed feature on your exam. This is your first major pattern. So let's break down the perfect way to answer it step by step.
Okay, first things first. Before you do anything else, you have to define the core concept. It's non-negotiable. Start your answer with this exact definition. Atomic radius is the distance from the center of an atom's nucleus all the way to its outermost energy level. Simple as that. Okay, now for part one of your answer, the trend across a period. You have to say this clearly. As you move from left to right across a period, the atomic radius actually decreases. Now why? Well, the reason is pretty simple. Even though you're adding electrons, you're also adding more protons to the nucleus. Think of it like upgrading a magnet. That stronger positive charge pulls all the electrons in a little bit tighter, and the whole atom just shrinks. And now for the second part of the trend, going down a group. This time, the atomic radius increases. And this one's even easier to explain. The key reason you got to write down is that with each new row, you're adding a whole new energy level, a new shell. And these new shells are just further out from the nucleus. So, naturally, the atom gets a whole lot bigger.
But wait, don't forget the second part of the question, ionic size. This is super easy to remember. Cations are positive, right? Because they've lost electrons. That means they are always smaller than the original atom. Why? Because you have the same number of positive protons pulling on fewer negative electrons, so they pull them in tighter. And anions? They're the opposite. They're negative because they've gained electrons, so they are always larger. That extra electron creates more repulsion, kind of pushes all the other electrons away, and the whole cloud just expands.
All right, trend number one is down. Let's move on to the next big pattern we see. These questions are all about an atom's, well, its relationship with its electrons. Basically, how badly it wants to attract them, and all the energy that's involved in that dance.
And let me tell you, this next one is a huge favorite for the examiners. I mean, the question on electronegativity comes up all the time. So let's absolutely nail the definition and the trends so you are 100% ready for it. And just like we did before, you're going to start your answer with that textbook definition. It's just the best way to start. Electronegativity is the tendency for an atom to attract electrons to itself when it's forming a bond with another element. Get that down first. Okay, now here's the magic trick. This is the most important shortcut you're going to learn. Electronegativity increases as you go across a period. Why? Well, that stronger nuclear charge we talked about, it's just better at pulling in electrons from a bond. And it decreases as you go down a group. That's because the outer electrons are way farther away and they're being shielded by all those inner electron shells. It's like they're blocking the view of the nucleus. But here's the absolute crucial part. This trend is the complete, total opposite of the atomic radius trend. Seriously, if you know one, you automatically know the other.
Okay, pause and look at this slide. This right here, this simplifies the entire unit. Just look at the table. If you can lock in the trend for atomic radius, that it decreases across and increases down, then you automatically know the trends for ionization energy, electron affinity, and electronegativity. They're just the reverse. This is literally your ultimate cheat sheet for acing this part of the exam.
Okay, so now that we have the main trends down, let's look at a couple of other concepts that pop up on exams.
Think of these as the behind-the-scenes reasons. They explain the why for all the trends we just talked about.
So, this question about polarizability, it's definitely made a few appearances. Let's break down exactly what you need to write down to get every single point.
For this answer, just think of it as a 3-point checklist. First, hit them with the definition. Polarizability is just a measure of how easily an electron cloud gets distorted or squished by an electric field. Second, list the key factors. It gets bigger when you have more electrons and a bigger atomic radius. And third, tell them the impact. Stronger polarizability means stronger dispersion forces, which bumps up melting and boiling points. Check, check, and check.
And this right here is the master key. This explains why all these trends happen. It's called effective nuclear charge, or ZEF. It's not the total charge of the nucleus, it's the actual positive pull that an outer electron really feels. And there's a simple formula. ZEF equals Z minus S. Z is your total protons, and S is the number of those inner electrons that are doing the shielding. It's this ZEF that gets stronger across a period, pulling everything in tighter. All right, time to put it all together. Let's tackle a really common combined question, one that makes you apply everything we've just learned about trends to specific blocks on the periodic table.
So here's the kind of question you'll see. And notice what it's doing. It's not asking you to learn a brand new trend. Nope. It's just asking you to apply the trends we already know, but specifically to the S block and P block elements. So your answer here is all about connecting the dots. It's a story of two halves. For the S block elements over on the left, you just say, hey, they have a large atomic size, which means they have low electronegativity. And what does that mean? They lose their electrons super easily to form those positive cations. Now for the P block elements over on the right, you just flip the script. They have a smaller atomic size, which means higher electronegativity. And so they tend to gain electrons to form negative anions. See, it all connects.
Okay, we have just walked through the absolute most critical, most repeated questions from this entire unit. So let's do a super quick summary of what you must remember when you walk into that exam.
Look, it all comes down to these 4 things. Get this, and you're golden. 1, master the trend for atomic radius. Decreases across, increases down. 2, remember that the other big trends are just the opposite. 3, know the definition and factors for polarizability. And 4, be able to apply all of this to the S block and P block elements. If you can do that, you've got the vast majority of questions from this unit totally covered.
So there you have it. That's the playbook. You've seen the patterns, you've seen the recurring questions, and you have the exact point-by-point answers you need. We've cracked the code. Now you're ready to go in there and ace this thing.